Hi everyone, and welcome to the next lesson on trigonometry. And this lesson is called the cosine law. And in this lesson, we're just going to explore the cosine law, and then in the next lesson, we're going to try applying it in more examples. So this is the last law that we're going to learn in this unit, and so it's the last kind of little piece of the puzzle that we have to put together. And essentially with the sine law, we started exploring something that we could use in non-right angled triangles. And what we figured out, and we learned how to use it, was that we needed to be given a side and its opposite angle. So the key was to be, if you were looking at a triangle, if you knew its side and its opposite angle, you could definitely use the sine law. But there's many examples where you won't be given that. And so in this section, we're going to examine the cosine law. And so basically, it's going to be the decision that or the choice that we use where we cannot use the sine law. Okay, so let's have a look. Let's go to the next slide. So look at these two examples. And so in the first one, triangle ABC, first of all, neither of these triangles is a right-angled triangle, so we can't use Pythagorean theorem, we can't use SOHCAHTOA, so we're looking at sine law. Sine law becomes our first option. But notice that in triangle ABC, that you don't have the side that's opposite the 78, so you don't know this, okay? And we also don't know angle A or angle C, and so those would be opposite the 7.8 and the 4.4. So and we can't get A and C, like we can't use the sum of the angles in a triangle as 180 because we don't know two of them. And so here's a situation where we cannot use sine law. So there's one example. And then look in triangle DEF here. In this case, you're not given any of the angles. And so of course you don't have an opposite because you don't have any of them. You have the side lengths, but you don't know any of the angles. So these are two examples. Both of these are examples where the sine law cannot be used. So in the first one, we said we didn't have an opposite, and in the second one, we don't have any of the angles. So we can't use the sine law in those cases. So we need a new method. And the new method is used in situations, and here it says the cosine law can be used to solve a triangle if either you know two sides and a contained angle, or all three sides. And what they mean by a contained angle, let's say we knew side A and side C, the contained angle, or the angle between those sides, would be B. So if we knew A, C, if we knew the sides A and C, and we also knew the angle B, we could use cosine law. And if you know three sides, so if you knew A, little b, and little c, you can also use cosine law. So here's what cosine law looks like, and I've given it to you in two different forms. But look at this. The one that you'll see most often quoted in textbooks looks like this middle one here. And so it says a squared, and remember little a is the side length, so little a squared is equal to little b squared plus little c squared minus 2 times b times c times cos of angle A. Notice that whole term, I'm just going to highlight this, that whole term, all of them are multiplied by one another. So it's 2 times b times c times cos of A. Those are all multiplied together. Okay, so now I've written it in other forms just to show you that it doesn't have to be side A that you don't know. But notice how something changes, is that if you're looking for little c, then it's got to be the angle C that goes at the end. Notice here, if you're looking for angle A, or sorry, for side A, then it's angle A that goes at the end. And if you're looking for the side B, it's cos B that goes at the end. So you modify the formula slightly based on what you're looking for. And then these three are just, I know they seem kind of confusing, but it's just a rearrangement of those three formulas. And so they're rearranging to get the A on its own, the C on its own, or the B, the angle A, B, or C on its own. And so those are good examples where you would use use cosine law to solve for an angle. And you're going to practice in your homework rearranging these. But essentially, you don't have to be perfect at it because obviously you'll have these formulas in front of you. Okay. One little quick note I wanted to make is that notice how this first part of the cosine law right there looks like Pythagorean theorem. A squared is equal to B squared plus C squared. We often see Pythagorean theorem look like that. The expression minus 2 times B times C cos of the angle A is there to compensate for the fact that triangle ABC is not a right angled triangle. So that's a little compensation factor that we use, but it's very similar. Okay. So here it is. The cosine law, I just want to emphasize this. It's the square of any side. So there it is. I'm using the version where we've written side C by itself. So it's the square of any side is equal to the sum of the squares of the other two sides minus twice the product of these sides. So minus 2 times A times B times the cosine of the angle between them. That's kind of like in words what the cosine law is saying. And I've just kind of put a triangle there with it. So in this case, if you were trying to solve for this side, right here, angle for side C, and let's say you'd been given B, you'd been given A, and you'd been given angle C, and your unknown was C, this is the formula you would use. All right, well, I want to try it now. So let's just try, and you're going to try this for homework as well, but let's try doing this analysis. And in this case, I'm solving for some unknown K. So this is the side of a triangle, the side K that I'm solving for. So let's say I wrote out my formula, and this is what I was left with. How would I do it? Okay, and I'd like you to try it along with me. So I've got my calculator in front of me. And so I'm going to do it gradually just to show you what you end up with. So 32 squared plus 35 squared. And I'm gonna write that. I get my calculator, I get 2249 minus, and then watch this, 2 times 32 times 35, so minus 2,240 times cos of 50. So I did that to get my 2240. I did that squared plus that squared to get my 2249. Okay, so here we go. So now what I'm going to do, again, I'm going to do this gradually. So equals, I still have to do the multiplication first. I can't do this minus this. A lot of students will try to do this operation right now, and they'll get 9. But you cannot do that because by BEDMAS, I have to do 2240 times cos 50 first. I've got to do that first. So here I go. I'm going to do 2240 times cos of 50 and make sure my calculator's in degrees. And look what I get here. I get 1,400, and I'm going to round it to 40. 1,440. So 2249 minus that, and I'm going to do that now. 2249 minus 1440 equals, and I get 809. Okay, but remember, that was k squared. Don't forget that that's squared. So the way I get rid of that is I take the square root of both sides, and so the k I get is, I'm going to do the square root of my answer. I get 28.4. Okay, so I just wanted to show you that. Like, a lot of you may get better at doing it more, like with less steps than that, but please be aware that you've got to you got to make sure that you are doing this properly to get the correct answer. Okay, well, let's say in this case we wanted to solve for an angle G. So in this case we'd been given all three sides of a triangle, but none of the angles, and so I wanted to solve for my angle G. Okay, well, I'm going to show you how I rearrange this. I'm not going to do any of my any of my multiplication or exponents yet. I'm just going to rearrange. So the first thing I'm going to do to try to get, I'm going to try to get this term by itself. I'm going to move the 17 squared and the 15 squared to the other side. I'm just going to get a different color here. I'm going to go minus 17 squared and minus 15 squared. Whatever I do to one side, I've got to do to the other side. Okay, so look at this. I'll end up with 13 squared minus 17 squared minus 15 squared is equal to negative 2 times 17 times 15 cos of angle G. So look at that. We got rid of the 15 squared and the 17 squared. Okay, now I want to get rid of this negative 2 times 17 times 15. Well, I'm going to divide this whole side by negative 2 times 17 times 15. Okay, and so, but whatever I do to one side, I've got to do to the other. So it's divided by minus 2 times 17 times 15. So look at this, that gets rid of it off this side, that whole thing, and now I'm left with cos G over here. Okay, let me get rid of that little dot there. Okay, so here we go. Let's now do this. So watch this, I'm going to use my calculator, and I'm going to go 13 second function squared minus 17 squared minus 15 squared. So try that in your calculator. When I do it in mine, I end up with minus 345 on the top, and on the bottom, it's minus 2 times 17 times 15, and I get minus 510. Now, because I have a minus over a minus, that turns into a positive, so it's 345 over 510 is equal to cos G. And then let's do that. So 345 divided by 510, and I get plus 0.676 is equal to cos G. And then the way you get the actual angle is you do the inverse cos. So you do the inverse cos of 0.676, okay? You do the inverse cos of 0.676, so second function, inverse the cos, and your answer is 47.4 degrees is the angle. So that's how you, if you were ever in a situation where you're trying to solve for an angle given three sides, you've got to kind of work through cos law this way. So just one more thing before you do your homework. This is a good, I wanted to walk you through, well, which do I use? You can see that cosine law is a bit harder than sine law. So in as many situations as possible, I recommend you use sine law. But let's look at these diagrams. And so in the first one, in A, it says you've been given all three sides. So unfortunately, you don't have any angles, any opposite angles. And so in this case, you'd have to use cosine law, okay? And just the reason is no angles given, okay? So in that situation, you've got to use cosine law. Okay, in B, you've been given one side length and two angles. Now, the fact that you've been given two angles, you may look at this and say, oh, well, I don't have the opposite to the 3.7, so I can't use sine law. But if you're given two of the angles, you can get the third by doing 180 minus 70 minus 59. So definitely in this case, I would use sine law. It's an easier one to use. Figure out what your other angle is here, and then use sine law. Okay? All right, let's go to the next one. The next one, look at this. You're given 72 degrees and its opposite side. As long as you see that, as long as you've got a side and its opposite angle, use sine law. Okay? And then this last one, so you don't have the side opposite 45, and unfortunately you're missing two angles, so this is the other situation where you've got to use cosine law. Okay, you've got to use cosine law. The reason is that you've got two sides plus the contained angle. And again, what we mean by that was that you've got these two sides here and then the angle between them. That's what those first, the A and D were the two scenarios where you've got to use cosine law. In these two middle scenarios, you have a side and its opposite angle. And its opposite angle, so I definitely recommend using sine law. Okay, so there's just a few questions for homework here. Give these ones a try. In particular, 2, I really want you to do A and C here. Those are important ones to practice using cosine law and to think about the other ones. I have given you answers on the last page, but certainly let me know if you have any questions. All right, take care, everyone.